Hello all, this is Priyadashni, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the same topic, performance metrics in classification. So in the previous lecture series, we were discussing about accuracy and the confusion matrix. So when you take confusion matrix, it is a proportion of the predicted versus the actual output. When you take confusion matrix, it consists of four important parameters like true positive, true negative, false positive, and false negative. The next metric we saw was accuracy. So accuracy works well only for balanced data set. For imbalanced data sets like cancer prediction, we cannot use accuracy as a prediction model. Now let's continue with the next performance metrics. The next metric we are going to discuss is about the precision. So precision is nothing but out of all the predicted positive, how many are actually correct. So the formula is given by true positive divided by true positive plus false positive. So we are going to predict how many correct among the predicted positive values. So precision is widely used when the false positives are costly. So the example dataset that can be used for precision classification is spam detection. It is a very important metric for spam detection like cases. The next metric used is recall. So recall is otherwise known as sensitivity. So this recall measures out of all the actual positives that has been predicted, how many are actually identified correctly. So this is about recall. So the formula to calculate recall is true positive divided by the true positive plus false negative. It is very important when the false negatives become a dangerous or a critical issue. For example, the cancer detection. So now let's recall the difference between the precision and recall metric. So precision, it measures actually how accurate or our positive predictions are. Whereas recall, how many actual positives has been captured correctly. So if it is a higher precision means there are fewer false alarms, and when it is high recall means it has captured all cases correctly. So this is the main difference between the precision and recall metric classification. The next important metric in classification to evaluate the deep learning model is FN score. So FN score is defined as a balance between the precision and recall. So the formula to find the FN score is 2 times the precision into recall divided by the precision plus recall. So this is the formula to calculate your FN score. So FN score is useful when if it is a imbalanced data set is being used, if it is using harmonic mean, and if it is penalizing the imbalanced thing. So for all these cases, we can use the prototype FN score. In the previous thing itself, we have understood what is FN score. So FN score is the generalized form of F beta score. So if beta value is equal to 1, then we call that as FN score. If the beta value is less than 1, it means that we are focusing more on precision. So when beta value is less than 1 like 0.5, then we are focusing more on precision. It has been used when the false positive we have to reduce. For example, like if you have to protect the important emails, then you have to give focus the beta value as less than 1. So if you have to give more weightage to recall, then you have to go with the longer beta values like more than 1, that is it can be 2 to 10. So based upon the necessity of the evaluation metric, we have to choose whether beta value is equal to 1 if both for recall and precision are equal importance or of equal weightage. If you have to give more focus on precision, that is if you have to reduce the false positive, then you have to go with the beta value less than 1, and when you have to give weightage more to the recall value, then you have to go with the beta values from 2 to 10. So this is all about your F1 beta score or F beta score. The next metric that we are going to discuss is about our specificity. So specificity is the opposite to recall. So specificity means that it has the ability to correctly identify the true negatives. So the formula is given as true negative divided by true negative plus false positive. So this specificity metric evaluation can be used when it is being used in the data sets like medical images, or if we have to analyze the anomaly detections in credit cards, we can use this specificity as a metric to evaluate the deep learning model. The next metric we are going to see is about log loss. So log loss is nothing but it measures the probability based errors. So this log loss can be used when we are penalizing the wrong predictions, or when we have to use for multi-classification models, we can use this log loss. So the log loss is based upon the expected calibration error. If the expected calibration error is equal to 0 or less than 0, that means that it is the best model. If it is infinity, then it is a worst model. So let's look at the example here given. So if 0 denotes that the model is a better model, if it is more than 0, that is if it is infinity, then it means that it is the worst efficient model for metric evaluation.